helping you, coming back to you. If the only problem is that I am not able to resolve that signal because there is a phase component associated with it. If I am in position to resolve it, then it should be an advantage for me, because signal which is lost is also coming back to me. So simply if you just look at it in a very, very elementary form, it's a lot more complicated than this one. Let's say I transmit two signals, using two antennas the same signal, and then I receive it two antennas and receive this signal. Now essentially what I have done is that I have, initially what I had was only, this is just for an example, take only two as an example, two paths are coming. I had two unknowns and I had only one equation to solve. I will not be able to solve that one because I have only one equation and two unknowns, x and y, but I have only one equation. Now I have two signals and two unknowns, I will be able to resolve that. So multiple input, multiple outputs, to a large extent, looks at it is that I have more number of equations now, so I can do a lot of signal processing and then retrieve the information as intelligibly as possible using multiple antennas. So that is the very broadly simple understanding of multiple input, multiple output. If I have several unknowns, I have several equations which I have created using multiple input, multiple output, I should be in a position to resolve it, and then I take advantage of the signal which was getting lost. So that is why my spectral efficiency is increasing, because my signal which was going somewhere else is coming back. So using that we can do that, and then there is something known as the beamforming technology. Let me see, I'll not go into the frame structures of this one. Orthogonal frequency division multiple access method, what uses, this is the exact definition of in LTE how the structure is done. What they do is, instead of sending in the third generation communication system, you send 5 megahertz of bandwidth, you use a code division multiple access. So every signal which you want to transmit, you use a code and spread the signal across all the 5 megahertz bandwidth and transmit across completely. But in OFDMA, it is not done that way. It is done in such a way that each component is divided into 15 kilohertz subcarriers. And several such subcarriers are called it as the resource grade, and 10 such frames are used. So don't worry too much about this particular frame structure, how actual implementation is done in a LTE. But 15 kilohertz is the small subcarrier which are used. So several such subcarriers you can use depending upon your requirement. If you are using for a voice, let's say you need only 2 subcarriers, let's say. But if you are using for a data which is just a static picture of not high resolution, you may need some 100 subcarriers. But if you want a full motion video which you want to transmit, which is very high quality of 4K TV kind of such thing you would like to do, 1000 subcarriers you would like to use. Depending upon the requirement, as and when it is required dynamically, you can use as many subcarriers as you want, and you have the flexibility of using that one. And that's the beauty of using orthogonal frequency division multiple access in the 4th generation communication system, is it gives you an enormous amount of flexibility in terms of the frequency components that you use, how many resource blocks you want to use. And that is the strength of the 4th generation communication system, which uses this technology. Oh, I'm sorry, what time? Another 5-10 minutes I should close, or 15 minutes? 15 minutes? Oh. I don't want to translate into someone's time. So we use these subcarriers and then use this network, and this is the architecture of system in the 4th generation communication system. And this is what MIMO and beamforming technologies are doing wonders. One is that multiple input, multiple output, multiple antennas transmitting gives you this spectral efficiency because of the principle which I explained earlier. And then another very interesting thing which has been used in radar technology known as phased arrays. If you have multiple antennas which are transmitting, and then for each of the antenna, instead of giving the same signal at the same phase, if you give at different phases, you can change the beam direction. And that's a very standard technique of phased array, where typically used in radars for scanning, electronically scanning the beam, the technique which is adopted. That has been borrowed in communication technology. Now the beam, what you are transmitting, can be changed this direction, whichever direction you want to scan, you can use that one. Or you could have multiple beams transmitting in one direction here. Let's say the concentration of people here around, for fun sometimes I give this classroom example, is that if I am giving a talk here and then you assume post lunch it is such a boring talk, the set of people close to the door walk out of this room, then why should I be wasting my energy transmitting into this section also? I can change my beam direction and concentrate only on this direction, such that the people sitting here can take advantage, or I can speak at a lower volume, or I can increase the range of this one because I can increase the capacity of the system. So that is the beam forming technology which can be used using phased array techniques, which is available in radar, that has been borrowed here. So it's a combination of MIMO and beam forming which gives several advantages. So these have been borrowed, several new technologies have been added, and various things have been included to increase the capacity, and this gives multiple input, multiple output concept here. And this gives you the architecture of this E-node Bs. E-node B is BTS equivalent of that one. So there are several such things which there is a interface between these two itself, which was not defined earlier. Here it had to come up to this particular point and then go back. Now this is, now considering that everything is in a packet network, the architecture has been redefined such that there is a distributed architecture which has been defined in the fourth generation, and that continues into the next generation communication system also. There are several releases. I'll skip some of these slides. In LTE, there is something known as LTE Advanced. LTE Advanced, there are several things known as, just briefly, asymmetric dimension and layered OFDMA itself. There is a layered OFDMA technique, multiple antenna techniques, extension of coverage, large bandwidth antennas. This gives in summary a comparison between LTE and LTE Advanced. The things which you had already mentioned about it, peak data rate, you can go up to 500 Mbps, 1 Gbps, scalable bandwidths, various other things. I'll skip some of this, persistent scheduling, carrier aggregation techniques, and few other important things in terms of change which have happened is I have spoken only about these structured networks, but there are several other unstructured networks. We have wireless sensor networks, we have Wi-Fi networks, Zigbee networks, Bluetooth networks. The whole these category known as personal area networks. It's comes under 802.15 IEEE standard. There is 802.16 standard of the WiMAX related areas, slightly larger area networks. There was another standard known as 802.20 standard, and then all these 3GPP standard networks, all this combination of that, but they were working in isolation. Now a Wi-Fi network was never talking to a mobile network. A 3G network and a Wi-Fi network, they are mutually exclusive to each other. But now standards have been defined so that interface between these two so that they can talk to each other. And that is known as heterogeneous networks. The headnets which have come up is the one where you have a combination of its advantage is the advantage of having such networks is that if you have a heavy load on the network in a 3GPP network, that is 3G or 4G network, and then there is a Wi-Fi network available at that particular point, can I offload the load onto that? If I have an interface built into this system, then I can offload the network from there to here, here to there, or network talking to each other. I have a Wi-Fi network, can I send a message to, from Wi-Fi, can I directly send into a network instead of getting connected through at the access point and then subsequently coming to the network through the internet hub? Can I directly connect between these two and then drop out? So that is the heterogeneous networks. And there are other networks known as femto networks, which has been redefined now, something called as small networks. The femto network concept is that if the network at the macro network is not able to penetrate inside. Many times you go into a basement, a parking lot and various other places, your mobile phone doesn't work because the signal strength is very less. So a mini base station has been created like a Wi-Fi router. It has been connected and it gets connected, it is put inside a room. Here somewhere at this particular point you put an access network of not Wi-Fi but the 4th generation communication network. And then that doesn't get connected to the base station. Through your internet, it gets connected at the central point at the point, this one. And that is known as a femto network. So that kind of networks are there, but that network designing becomes a little more complicated because the macro network which is there, this micro network of the femto network is embedded within this one. So the interference related issues have become very complicated, but you need to design that. There is an interference which is happening between one femto and another femto and the macro cell. So all these related issues, because they could both be operating at the same frequency or different frequency. If they are operating in the same frequency, you need to design in such a way that the interference management happens. So those things are taken care and then done that. So these are carrier aggregation using interference management, and then this is the collaborative MIMO. MIMO extension has been done, a lot of research people, I'm sure many must be doing here also. The MIMO is, a simple MIMO is between your handset and the base station. But you could have at a collectively between the base station and base stations, how the interference happens, and then, so we are working on various related issues of interference mitigation techniques, because once you start refining the networks and improve, you are coming to a threshold point, then the interference becomes the most important parameter that has to be managed. The interference management mitigation becomes very, very difficult, because it is not difficult if you are close to the base station. But if you are at the periphery of the base station, then you are closer to another base station, the management of interference becomes difficult. So there are several techniques, and this is the base station which has been designed. First it was designed by Alcatel-Lucent, then of course now Ericsson, Nokia, various other people also have come, that they have made a base station which is typically of the size of this podium, this size. It's typically a box of this size, which is after which the RF is taken and then you take it to the roof, top of the tower, and then you transmit the signal. That has a serious disadvantage, primarily because the power here, what you take it out, if you want to transmit 1 watt power outside, you will have to generate 2 watts power here, because at least 3 dB loss will be there, because the RF cable will be very lossy. So the idea is that can I push this box itself to the top so that I reduce that amount of this one, but this is too bulky. So you'll have to make it into a small size. So that was the exercise which was done, and this is the antenna, this is the RF part of it, this is the digital signal processing part of it, this is a system on a chip which has been done, and then the power supply for that is put here. And the capacity, if you need larger capacity such systems, several of those things you can stack and then use that one. So that is how the integration has reached such a level that the base station has been brought to size that you can even hold it in your palm. Then the whole thing can be mounted right there. Then all the RF losses are reduced, because the cable length is now reduced. Only the digital signal, from here only the digital signal will come down. Digital signal losses will be nothing. You can run as long as a wire as you need. This one. And then I will skip these things. I think probably the 5 minutes, or I just want to show this is machine-to-machine communication is what is most important. Is about the Internet of Things. So there are several standards in this. Hundreds of standards, proprietary standards were there. This is IETF has designed 6-low-PAN personal area networks, and then there is a ZigBee alliance, and then there is a GSMA alliance, 3GPP alliance, various other things which are there, which are working on that one.